When you think about data engineering as a class of problems, it's a branch of software engineering where the art of the possible is infinite, right? Like every business's data is going to be unique in its own certain way. The way Nike runs its business is very different from the way that Lululemon runs its business. The issue is getting to a state where you have high quality data in your data warehouse that's accessible by an LLM is incredibly difficult. That type of integration work is why data engineers get paid the big bucks.
Context in general is super critical. How are you guys approaching that?
You reduce the surface area of what a developer has to interact with or what an LLM has to interact with. You can put more into the context window. The LLM can iterate quickly, and when it creates a new data pipeline, it can immediately test that data pipeline and see if what it created worked.
Wow, this is a massive opportunity. Today we have the founders of fiveonefour, Tim and Chris, joining us. I'm very excited about this episode. I've heard hey, data engineering is not an agent for X problem, and these guys are deep domain experts. Chris and Tim founded a company called Datalog, which was acquired by Nike, where these guys ran the data engineering function for several years, and now they're building a new company, fiveonefour, which is leveraging generative AI to solve the data engineering problem. Welcome, guys. Excited to have you here.
Hassan, excited to be here, man.
Thanks for having us.
Yeah. So, in one sentence, why is it not just add an agent, let's solve the data engineering problem, let's create natural language query? Can you tell me that?
I don't know if I could do it in one sentence, but at a high level, if you think about let's say an agent for insurance, right? An insurance agent might get a claim, adjudicate the claim, and then tell you whether you're going to get paid for whatever wreck you might have gotten into. When you think about data engineering as a class of problems, it's a branch of software engineering where the art of the possible is infinite, right? Every business's data is going to be unique in its own certain way. The way Nike runs its business is very different from the way that Lululemon runs its business. And the way that they think about the world, their supply chains, and all of those things are very unique to the way they operate. And so when we try to really think about kind of the data landscape and data engineering as a whole, and we try to apply this this agent for X type of mindset, we oftentimes find ourselves running into pitfalls where one way of thinking about data doesn't apply to another way, to the specifics of the company. And so the way that we like to think about solving the data engineering problem with generative AI is to empower data engineers in the same way that we've been empowering software engineers on the agentic kind of development mindset. So we want to be directly in their IDEs. We want to empower them to leverage the tools that they know. We want to empower them to use the quality controls that software engineers are so used to when doing work. And we are strong believers that by kind of fitting directly into the way that data engineers do work on a day-to-day basis, you empower them to leverage generative AI for what it's good, which is generate a lot of code, and then empower them to use the quality controls to make sure that code's safe in production. So we think of data engineering as one of these very, very broad categories of work, very, very similar to general software engineering approaches.
No, I think that's a great point, right? So you have these frontier labs Codex at OpenAI, Claude Code, Gemini, Google has their own kind of approach as well. But none of them have kind of tried to tackle the data engineering problem. In your perspective, why is that?
The main, I think, issue that most of these frontier labs have when thinking about the data engineering problem is context. And when you think about your enterprise data, that enterprise data typically doesn't live on your software developer's laptop. And so we need ways of enabling the developer to pull some of that enterprise data locally, which is where they do a lot of the work, using the Claude Codes, the Codexes of the world. And they need to be able to get access to that context directly inside their IDE and where they actually do the work. And so when when we're looking at kind of the frontier labs, you typically don't see them kind of tackling the full end-to-end workflow. You see them kind of really tackling the generic software development workflow and missing kind of that enterprise context, which requires a bunch of security access controls, which requires scalability, which requires local first developer experiences. And that's where we really kind of focus a ton of our time, is in pulling that enterprise data context locally so that the developer can be productive.
So where do like current approaches, which you have seen in the market, fail in really like leveraging this experience for the data engineer where like they can get meaningful outcome leveraging LLMs in your opinion?
I think there's kind of two aspects to that. One is the first one, which is becoming almost table stakes, is in enabling a human to ask natural language questions of their data. So many capabilities today, including ChatGPT, if you have kind of the right integrations, will enable you to ask questions of the data that's really well documented and really well stored within, say, an enterprise data warehouse. And like Snowflake, for example, has an agentic capability that enables that type of workflow. The issue is getting to a state where you have high quality data in your data warehouse that's accessible by an LLM is incredibly difficult. And so that's where a lot of the time is spent for data engineers, where you might be trying to take data out of a transactional system that you're using to run the vast majority of your like applications workflows, and get that data into kind of these dedicated analytical systems like your data warehouse. And that type of integration work is why data engineers are specialists in the software engineering field, and why they get paid the big bucks. And so we as a company are very focused on the development side of the world, where we empower these developers to move the data from one system to another, bring them into the capabilities that are incredibly high performance, that can crank through an enormous amount of enterprise data, and enable them to do so in the tools that they're used to. So like in Cursor or in JetBrains IDEs, where they live and breathe.
You mentioned Snowflake. So when I was at Snowflake, right, like I would see like a lot of companies who would be like, hey, we are your best friend for generating an SQL query via natural language. And a lot of them would just not work. And I started looking deeper into that. I was like, hey, one, building that query from natural language is not an easy job. And then second, as you mentioned, right, like sometimes the data does not even sit in the right data warehouse. A lot of times, like the issue was that the query they were trying to create, the data was not even being collected, like instrumentation didn't exist. So I was like, man, damn, this is like a pretty hard problem. Getting the right query, making sure the data is even sitting in the right place, instrumentation exists, and really open up my kind of vision. Like, wow, this is a massive opportunity.
Yeah, like if you take a very simple example, back in our Nike days, we always joked that answering the question, "How many red shoes did we sell yesterday?" is a very difficult question to answer. And that's for two, like, for most shoe nerds, right? Like, that seems simple, but, like, the definition of red for an enterprise of Nike's scale is actually a very hard problem to solve for an LLM that may not have the context of how you're actually storing your data. Like, you might be storing your data for a particular SKU with Pantone codes, and an LLM doesn't necessarily know whether you consider burgundy to be a class of red, right? And
Yeah.
how you go about kind of asking these questions, like if you're an analyst and an executive were to ask you, like, get me all the red shoes from yesterday, you would probably ask a follow-up question like, what is yesterday? Are we talking about China time, or are we talking about New York time, right? Like, and those answers are going to be very different. And when you look about that particular problem and you try to truly solve it, it's about bringing in the metadata and the context about the data into the LLM, and that's a very, very difficult problem in of itself. And that's where things like MCPs, things like different enterprise integration layers are so critically important to solving this problem. Whereas they're not really that important, or as important, when you're talking about general purpose programming. If you're just writing an API for, like, a generic CRUD API for a database that you own, you just need the context of that single database and what API you're writing. you don't necessarily need to understand the concept of Pantone colors when someone is asking for the question, get me all the red shoes. Um, and so that's where there's a huge delta between what's accessible today to LLMs and what is actually required to answer these questions, and why a simple kind of query to SQL system is actually very hard to build.
So it seems like context specifically around, it could be time, could be type of the color, like, just context in general is super critical to do this. So how are you guys approaching that today?
So for us, context is absolutely king, and we solve it in kind of two fundamental ways. One, there's the local context for the developer. Um, that local context really centers around the local development experience where you get access to logs. So like the LLM and the Copilot extension that we've built has access to all of the local kind of experiences that you as a developer normally see. Like in your dev server, you might see all of the log files come in. You've got access to all of the code that you're writing. You've got access to all of the kind of debugging statements and things that you would need to write high quality code. So that's one part of context where we think things really matter. There's a second piece which matters a lot, which is what we consider to be remote context. And this is really your enterprise context. So this could be as simple as your definitions for what PHI or PII might be for your organization. Nike was this massive global brand, and it had operations across the globe, including in Europe, where GDPR is very important and where you need to be very sensitive with people's private information. And so having these policies that aren't just like stacks of papers that someone has read once and never goes back to, embedded directly into your LLM and your code base, means that as an engineer is writing code and they're building a pipeline that might have sensitive data, the Copilot might recommend like, hey, maybe you want to hash this particular field that you're processing in your pipeline so that you don't end up exposing someone's private information downstream. You may want to remove, maybe you're a medical provider and you may want to remove medical identifiers so that you're doing analytics on kind of aggregate populations as opposed to individual patients. And historically, those types of things have required engineers to dive deep into the policies and understand the regulations for the enterprise. And now we can just kind of embed this directly into the context that the engineer has access to. And for us and some of our customers, we were working with a large liquor distributor, and in doing kind of this work, their first pass at solving this problem with a human looking at the policies and then trying to apply them was something that would take many hours and days. And we literally were building a pipeline that was injecting all of the contacts in front of them in like 15 minutes in a live call. And so that's the type of acceleration that can be put in place here, where you can get full remote contacts plus your local contacts, merge those two things together, and then deliver a pipeline that's both high quality from a coding perspective, but also high quality in terms of its adherence to your enterprise policies.
That's awesome to hear. And one question I was very excited to ask you guys is that, so you built a company during the SaaS era, which kind of solved the data engineering problem. You guys then went and Nike kind of worked at one of the biggest companies, which is where I assume data engineering is a pretty big division and it's a very critical piece of like how they do business. And you're now back at it in this new AI wave, solving a similar problem. What are the key changes you saw in the technological stack, and how is it different from like being a large company to like, being a startup? Like, how's that different right now as well?
Yeah, maybe I can jump in here. So the first company we built was called Datalog. It was a data pipelining and ETL company. And it was at the highest level, actually, we were still focused on the same kind of fundamental challenge, which is that data engineering is this really hard problem that requires a very specialized skill set. And businesses want to become more data driven, want to be faster with their insights, faster with their automations and their analytics. And we were tired of seeing teams like bottlenecked on data engineering. We're like, we want to open up this bottleneck. And at the time, this was 5 or 10 years ago, AI was at a very different stage, and we were actually embedding AI into the pipelines, but we were training our own core models on how to do mapping, how to understand data. Like there weren't these foundational models that we could leverage. So it was a much heavier weight problem. But also we took a fundamentally different approach at that time, which was the hypothesis was data engineering is really complex. Let's simplify and abstract it away so that non-technical folks can do the work of a data engineer and unblock themselves on the insights that they're trying to get. And we created nice, easy to use GUIs with point and click interfaces and very like non-technical friendly experiences. And what we found was that yes, that actually was quite effective at enabling non-technical folks to do interesting things with data, especially when you took the custom built AI and applied it to it. But there was this really painful long tail effect of it where it made it really easy to get things into production, which were then hard to impossible to actually manage in production because they were developed by kind of AI and a non-technical person. And you ended up with this like data swamp of a million different data pipelines, a million different data products. And when you ask how many red shoes did we sell yesterday, you get 20 different answers to the question based on whatever like point and click pipeline the business executive created. And so this time around, we had a fundamentally different thesis, which is that yes, data engineering is too complex. And yes, we want to open the floodgates on being able to do it. But the answer is to go towards the developer as opposed to towards the non-technical person. And there are 10 times more software developers in the world than there are data engineers, maybe 100 times more. It's orders of magnitude more. And we come from a software development background, and we know the power of working in code, working in your IDE, working with version control, working with testing and CI/CD, and all of these things that build governance best practices in so that you don't create a swamp with your software. And we set out at the time we were starting the company, frankly, to enable human developers, generalist human developers to do the work of a data engineer. And we did this by doing things like creating frameworks which have dev-friendly abstractions and reduce the surface area of what you have to interact with as a developer. We did it by creating a great local developer experience so that you can iterate on your laptop very quickly and see the impact of the code changes that you're making. And we did it by creating a managed infrastructure that takes away the whole problem of like, how do I manage this thing in production? Because we're going to manage it for you, and we're going to give you a great developer experience with that as well. And what it turns out, which I'd like to say that we were like predicting the future when we did this, is that the same kind of things that help a human developer be more effective at doing data engineering are exactly the same things that help an agentic developer or an LLM do the work of a data engineer or co-pilot with a data engineer. When you reduce the surface area of what a developer has to interact with or what an LLM has to interact with, you can put more into the context window. The LLM can do more effective development with that. When you give it extra context, all those things that Tim was talking about, and you do that locally, the LLM can iterate quickly. And when it creates a new data pipeline, it can immediately test that data pipeline and see if what it created worked and get the error codes and the status codes and the logs and keep iterating until it gets something that works. And then when it's ready to go into production and it can run a single command, and you push your pipeline into production, and now you've got something that's working. It's not always quite as simple as that, but essentially pivoting towards let's enable a technical developer opened up this whole world of let's enable LLMs to do this work as well.
That's amazing. So if I'm today a software engineer, or like, just a technical person, and I have to work with a lot of data, like how would I be able to leverage 5.4 like in my day-to-day? Like love to understand that. And if like, we could see a demo, that'll be amazing as well.
Yeah, I think this is probably easier or maybe not easier, but more fun to show than to tell. So let me share my screen here and we can jump right into it. So what I want to show you is like, this is an example application that you might be building that's data driven. What we're looking at here is an application that's built on a data set that's aircraft transponder data. It's all the different aircraft that are in the air at any given time. It's available from an open API endpoint. So it's a fun data set to play around with. And the first thing that you'll notice here is that This is not like a classic BI, dashboard that's created within a BI tool. This is a custom application. And more we're seeing that data engineering isn't just being used for internal BI or even data science, but for embedding real-time analytics and OLAP capabilities into applications. And those could be custom applications like this. Those could be agentic applications. But a big part of what we're enabling is engineers to get analytics actually into their application and make that integration as seamless as possible. So here we've got, data sliced and diced by altitude, by speed, by different aircraft categories. And as a data engineer, if I pick up this project and I want to create a new data product here, slice and dice this data in a different way, I need to actually now dive into the data pipelines and the data products and the API endpoints that are powering this application, and hopefully very quickly wrap my head around all this and be able to start to make changes in it. And so I want to show you what that looks like when you're using the 514 platform here. So I'm now into my IDE. This is my developer environment. I've got my my MooseStack project open here. And MooseStack, by the way, is our open source developer framework that we developed at 514. And what you'll see is that a couple things are going on here. First, in my terminal, you'll see there's data flashing by, and that's happening because I've got my local dev server running. With a single command, I ran moose dev, and what that's done is it's spun up a local mirror of my entire production analytical infrastructure so that I can develop locally. And as I'm making changes to my code, those code changes are going to be hot swapped in, and I can immediately see the impact of those.
So what I understand right now is that, the most important thing you said is, if I'm a data engineer picking up this project and I'm like, hey, instead of me trying to figure out where this data is sitting, building up the database and all of those things, you can just leverage 514's kind of 2-3 lines of code or API and just get things going locally on my machine and see what the impact is.
Yeah, exactly. It's just like a modern web development experience where when I'm creating a web application, I just create a branch, I pull that branch down locally, I run my dev server, and then suddenly that's available in my browser. And that's literally what's happened here. I've got a Next.js project here.
It just reminds me of just very similar to a Cursor experience today. From Cursor, you're coding something, you want to see hey, the local host kind of shows up, go click it, see what the impact is, very similar to that.
Exactly. And then as a developer, if I want to orient myself to this environment, I can of course go around and poke in the code, and it's structured pretty cleanly with the MooseStack framework. But I can also now start to use my AI copilot. So I can do something really basic, like tell me about what's going on in my MooseStack project here. And I'm gonna be live vibe coding here and interacting with AI, which is always fun in live demos. So we'll see how well it does. But you can see right off the bat, the cursor here, my copilot, is not just kind of scanning the code that it has already available as context. It's immediately going to the MooseStack MCP, which is the local server that enables that exposes tools to the LLM to gather that type of additional context that we were talking about before. So it's running a tool to get a map of the infrastructure that's actually running locally in my dev server. It's pulling the recent logs. It's actually querying the data in the underlying database. And it's now able to answer what's going on in my application, not just with a summary of the code and the kind of the semantic architecture of the code, but literally what's running in my application. And it's telling me oh, the source data is coming from this adsb.lol API endpoint I was talking about. It walks me through the whole flow of the data. So it's coming in through this connector, which is ingesting the data.
You can understand the grounding, you have guardrails, hey, there's no hallucination. There's exactly, if you want to go validate this, you can do it.
Exactly. Yeah. And all of this is in the code right here. So if it did happen to hallucinate something, which I don't think it did here, I can go and validate it. So it's okay, it's saying that, your ingestion is coming through the fetch and ingest military aircraft connector here. And I come over here and look at my connectors, and here's the actual connector that it's talking about.
That's super cool. So in essence, the core thing then, if I think about the value kind of value add here is that, hey, if I'm a data engineer, I need to worry about making sure the data is sitting in the right database and it's good and good to go. And then you can kind of leverage 514 to do everything around it, in essence.
That's right. Because you essentially, when you're trying to integrate analytics, or especially perform in real-time analytics into your app, there's two layers of things that you need. First, you need the database itself. And for real-time analytics, you need an OLAP database. You need an analytical database. That's what's going to give you the performance on the queries. That's where your data is going to live, and you want it structured in the right way. And we love ClickHouse. It's an open source analytical database, which is really popular, but there are lots of great OLAP databases out there. But a database, even a high performance database itself, doesn't give you a high performance application. You then need all of the accoutrements around your database to actually integrate it into your application. So you need your connectors to ingest the data. You need streaming buffers to maximize the performance of the data coming into the database. You need API endpoints and a whole backend service built around the database. And you need that integrated with your existing transactional stack or your existing data pipelines, whatever's there. And now what I've got, and I can actually show you this exactly how it happens. I'll stop this and run it again in a second. But with a single command, I'm going to type moose dev, and that's going to spin up this whole local environment that has not just my database, but all the other infrastructure that I need around it. Here, I'll do it live. I type moose dev, it's now spinning up ClickHouse in a container, Red Panda in a container, Temporal in a container, and it's putting in place all of the kind of best practice glue and duct tape to piece together those things for me. So for the data engineers watching this and maybe the developers, they would probably know, like, this is a couple hours of work, maybe a couple days of work to create this local dev environment, and we're doing it in a single command here. And that's all about just giving you the environment to be able to iterate in, which I can go next into what it looks like to actually do that iteration. But yeah, this is kind of getting the setup.
That's amazing. So you guys are, to some extent, the cursor for data engineering.
Yeah, and the beautiful thing too is it works right in Cursor, right? Like
Nice.
Chris is in Cursor. We extend the capabilities of Cursor, and we enable Cursor to be your data engineering sidekick, not just your programming sidekick.
Yeah, no, I was leveraging Cursor the other day to like do some like design work, and I was like, oh, this is super cool. So like, yeah, that's another kind of like application. If that's your preferred IDE, then you guys can operate within that.
Yeah, and the beautiful thing too is we can extend every other kind of agentic capability. So we support Cloud Code, we support Codex, we support Windsurf.
Nice.
And so we've decided that we want to enable all of these kind of agentic experiences to do data engineering, as opposed to build our own agentic experience from the ground up. Like we're starting to brand that product as Copilot Plus, where it's just like it's a Copilot extension. It's not the Copilot itself, and we're having a lot of fun integrating into those other products.
That's amazing.
I'll give one quick preview of the actual like generative side of this. So far this has all just been getting context, but the fun part of data engineering is actually building new stuff, right? So like right now we've got altitude and speed surfaced by different aircraft categories here. But like, let's say we wanted to build out a new derivative data product here where, like, I don't know, like, so like these categories are A0, A1, A2, A3, like those don't mean anything to me. I'm not an aircraft expert. What if we want to like enrich this data with some better category information? So now I can go in and just start, having a chat with my Copilot and asking it to do this
just like randomly. I don't know if like this even is included in the data, but like would be curious to know, hey, like how many president, or like because there's the United Nations Summit this year. So like, hey, which countries flew in on private jets would be really interesting to know. Like, I don't know if you can track that.
I'm not sure if that's in this data set, but that's exactly the kind of question that we can ask here. So we can say like, do we have country source data for flights in our data set? And let's see. Okay, so now it's querying the database. It's checking what data is available there, and let's see what it comes up with.
Oh, no direct country.
Yeah, so we don't unfortunately have the source country in this, but there's, indirect indicators of where the country might be coming from. Like, this is what's cool. When you get an LLM that's trained on the total sum of humanity's
Yeah.
knowledge based on all the information in the world, and then you give it the specific context of the data that you have, it can come up with cool insights of like, oh, I could probably guess that something's from German if
That's
it's got the
interesting. It
F
gave you the
prefix to it,
proxy. Like,
right?
didn't just say like no, but it actually gave the proxy. Like, hey, there are call signs, tail numbers, registration numbers, so people can figure out like, hey, who's registered where, and you can go further from there.
Yeah, exactly. Okay, so let's say like, okay, maybe this registration number, we want to play with this a little bit more. So let's say like, do we have actual good data on registration numbers in the data set? And if we actually have good data here, then we could go and maybe try and generate an insight from it. So what's cool here is you'll see it's iterating very quickly against the underlying database. And to your point of like the LLMs aren't great at writing SQL, they're not. And we're seeing that in action here. Like it took it 7 different tries to get the right SQL query. But because we have a database underneath all of this that's highly performant, can handle getting pounded with broken or unperformant SQL queries, it's no problem. We're not racking up a huge bill in production. It's all running locally on my dev server. So like all of these things are requirement to having AI native data platforms and AI native data warehouses. Yeah, so here we go. Data quality looks good. We got the majority of the records have a non-empty value. We've got all different values here. So, okay, cool. Let's go ahead and say, create a new API endpoint for me that it gives the average speed and altitude for a given registration number. And now we're getting into like proper data engineering work, right? Like we're not just understanding what's going on. We're not just doing analytics on our data. We're building out new infrastructure that can power new applications. And now it's going to go out and it's going to go through these different steps of trying to create the new API endpoint. And wow, it did that very quickly.
That's
here we go.
That's pretty fast.
Yeah, so here we go. New API endpoint, aircraft stats by registration. And the reason it was able to do this so quickly is because of the Moose framework, right? So the framework is abstracting the underlying surface area, giving it these simple primitives to interact with. And then here you can see the Moose dev server is automatically processing those changes, spinning up our new API endpoint in real time. It's going to automatically document that API endpoint using the Open API standard. And now I can tell my LLM, test that new API endpoint and make sure it's working. Use the logs if you need to. And let's see if it was able to actually one-shot an API endpoint or not.
That's pretty cool. Like actually the best thing I love about like the new Sonnet 4.5 with the in Claude Code is like, hey, you can actually test, and like even if it takes like requires minutes and minutes, it can just run on a long horizon. So that's awesome to see. Like that makes a lot of sense. You can just do the same here.
We can see it made an error and it's fixing the error as we speak.
Yeah, this just like to me feels like a software engineering experience now fully.
Exactly.
That is exactly the point. Yep. Yeah. So it's able to, like, this is all just TypeScript, right? Like it's not some like YAML based configuration. So we get end-to-end typing. It's able to get dev time compilation errors. And then it's able to, once it gets the TypeScript compiling right, it's going to implement the changes. Now it's going to actually try to curl that API endpoint. I think it failed because the API endpoint hadn't actually spun up yet in my dev environment. Let's give it a second to bring up the new API. But in any case, I know we're maybe running a little long on the demo. But hopefully this gives you a flavor of like how context, iteration speed, simplified surface area, AI safe environments. This is what enables like proper modern AI driven data engineering. And even more importantly, proper modern software development where you're trying to integrate analytics and data engineering best practices into your application.
No, this is awesome. Really, really appreciate you walking through the demo. And I think like people will love this, right? Like, because I think a lot of times you hear about like, hey, this is how I solve data engineering. This is what I'm trying to do. But like, it's great. Like you guys walk through like a real example where you're able to like show someone from scratch, like, hey, this is how you can set something up. You can, and it's open source, guys. So like, yeah, go test it out and try it. So to wrap up, like one thing I always love hearing from folks is how are you using AI in your own native kind of stack, right? So like Tim, you're the CEO of the company, running this company. Love to hear from you. Chris, you're on the product side. From your perspective, how you're leveraging AI. Love like a perspective.
Yeah, I've got a personal ChatGPT Pro account that I like that's my splurge in the AI ecosystem, and I absolutely love it to death. And I'm connecting it to a whole bunch of different systems. So the the first thing that I do is I use a pretty like bare bones markdown note taker. I use IA Writer, and I take a lot of my notes in Markdown, and I connect that directly to my Google Cloud account so that I can get my notes in ChatGPT and kind of run most of my life there. I recently got a little limitless pendant, so it's like a speaker, it's like a mic that you wear, and it can be always on.
Nice.
Yeah, it's a lot of fun, and, like, my wife and I will use it on these, like, long conversations and, like, remind each other, like, yesterday, I was like, "Oh, shit," like, we were talking about this topic, and I wanted to take a note, so I just grabbed the pendant, and it was like, "Hey, by the way, just remind me of this tomorrow," and I have access to it. Um, so I'm doing a lot of that, and I think, another kind of part of my AI stack, is, like, I've got 2 very young kids, one's 1 and the other one's 3, and I absolutely love my Meta Ray-Bans, and I love just being able to, like, say ask Meta to just capture a quick clip as I'm wearing my glasses, and that's, like, my, like, modern dad, like, luxury of just, like, being able to snap up something.
I was thinking of getting the Meta Ray-Ban. So that's like, like I've been hearing mixed reviews, but like my main purpose of use case would be like, hey, I don't need to take out my phone and take a picture of my daughter. But like, okay,
Exactly.
that's good. So that's like convinced me. I'm gonna go buy one.
Exactly, or like I have to go to ballet with my daughter, and it's just like you're sitting there doing little twirly twirls, boop, snap it, or ask Meta, hey, grab a clip here. So I've really loved that in my personal life, and then at work, obviously we're enabling AI across development and product management in all of the different functions.
Chris, from your perspective, like how do you use it like at work, like personally?
Yeah, it's funny. Like, despite being a serial entrepreneur and spending my whole career working with technology, I'm kind of a technology skeptic. Like, I'm a late adopter of new technology all the time. I'm a creature of habit. I like my patterns, my things that work. And I was not an early adopter of AI tools. But man, this stuff is powerful, and it's super compelling, and I'm fully in the deep end at this point. I don't have hardware on my body like Tim does, but yeah, anytime I'm in the code, of course, I'm using AI copilots, which you saw in the demo. The Granola is a personal favorite tool of mine for note taking and doing AI summaries with meetings, because I'm in meetings all the time. But the kind of the more interesting journey I've been going down recently is moving from my regular like ChatGPT usage, going from like quick chats, quick answers, and like going to it when I need something fast, to learning how to work deep research into my workflow and getting comfortable like sending the LLM off on a 5-minute, 10-minute, 30-minute expedition to go like be an analyst for me and go do a bunch of research that would have taken me or someone on my team probably a couple days to do. I mean, maybe an afternoon to do, but I can get it's not a senior analyst, but it's a junior analyst. And if you get better at prompting, you get better results. And that I'm looking forward to the feedback cycle where what takes a 30-minute loop now gets down to 30 seconds. And I feel like this is going to be, I'm going to date myself here, or like age myself, but like I feel like this is going to be my generation's like AOL dial-up, where you used to have to sit there waiting for the thing to connect and make the crazy noises, and now it's like the internet snapping, you get answers in a second. And I think it's going to be really cool to see how powerful this stuff is when it's operating at orders of magnitude faster.
I think it's going to be super exciting, right? Like, yeah, the next 12 to 18 months, you see how this agent framework start getting adopted, enterprises, consumers, and being able to have an autonomous system where, if you're grabbing like an Uber ride, like it should be able to send a message to wherever you're going, or if it's a Friday date night coming up, it gives you options that you books like with your wife, date night things. Like, truly autonomous systems. Like I'm very excited about that. Like, like making your life less frictionful and meaningful as well. So you have time for like more fun stuff. Taking pictures of your daughter with like the Ray-Ban.
Totally.
Ballet every day.
No, this is awesome, guys. I really appreciate you guys taking the time, walking us through the demo as well. Hopefully the audience loves seeing how data engineering is being changed by 514. And you guys should all go try the open source Moosestack stuff like these guys have put out, which will allow you to like do these things locally as well. But is there anything else, Tim, Krish, you would love to say before we wrap up?
Over the next kind of quarter, we'll be releasing a lot of our latest and greatest agentic capabilities. And so we're hoping to have automated migration agents out in the wild very, very soon that enable you to migrate from from your transactional kind of database to your OLAP database very quickly. We're working on products that help you source data. When you mentioned that Snowflake, when you were there back in the days, that oftentimes the data wasn't even present in the data warehouse, and then someone needed to go in and instrument the data. So we're going to be launching an agent around that type of capability. And then oftentimes there are cases where it's not just the data exists and it's living somewhere and you got to bring it in, but sometimes you actually have to instrument it directly into the application and capture an event. We've got a lot of work also happening on that front. So I think if folks want to stay tuned on our developments, highly recommend keeping up with our change logs and joining our open source community. It can be found on our website, 5onefour.com.
Amazing. Again, thank you so much, guys, for joining. And I'm excited to have this episode out. Thank you so much.